All right. Well, I've already been babbling a bunch. So my name is Robert Rodgers. We don't really use titles internally, but my title is Chief Architect at Skyport Systems. I'm also one of the founders. I founded the company with Will and Michael. I'm going to talk to you about not branches or branch-ish kinds of things. So we've kind of been babbling at you guys. We've shown this slide a couple of times, and the point we've been making is so far are mostly things around here. And obviously, we feel that your bulk computing space kind of evaporates and moves out. It's kind of like a reverse terraforming process where the cloud, instead of terraforming the data centers, is lifting things into space and taking them away. I'm going to talk about what we call remote branches or branches in general, but I don't think that they stay branches in the traditional concept. So if you go back in time, traditional branches in the compute sense are these things that were they were storefronts, they were distributed branch offices, they were they were things that came out of existing locations that needed compute services to be wedded into them, because a lot of the companies where branches really showed up are large companies, which tend to be older. In our view, though, the interesting part of branch is actually sort of the emerging market for what branches are. And so if you think about we do this ourselves, so Will talked about it. We have compute at our manufacturing site that connects to our network and communicates with us. And a lot of people who are doing manufacturing, especially contract manufacturing, they need to have something custom that they own and maintain and remotely manage. It's a kind of a branch. Industrial IoT, not to be confused with home automation, but industrial IoT is things like there's Predix for GE, there's all sorts of things like that. Actually, it's surprising how much compute is on, say, an oil rig. There are racks on oil rigs where they have compute there. Computers show up everywhere because they control equipment, they distribute software to other equipment, and so on and so forth. The typical deployment cycle kind of looks like this, and we've got it on the slide, but I'm going to do it from memory because I know it really well. Typically, you order something. It shows up at your shipping depot, your receiving depot. You take that box of gear, you take it into a lab, you install some software, you vet it, you maybe do a little bit of burn-in if you're really lucky and your company gives you the time and the staff to do it. You do some pre-prep, so you'll do things like configure your BIOS, install your bootloader, install your operating system, install whatever. Then you'll repack it, and you'll ship it out, and you'll ship it to your Chipotle branch or wherever you're using it. And then someone will eventually fly out, and the branch will have received the box, and it'll be put in the back room for a while, and then someone will fly out, and they'll unpack the box, and they'll rack it in. And then they'll do sort of last moment configuration. So typically networking is one of the things you have to do on site. A lot of people, if it's a Windows box, strangely enough, a lot of people will half install Windows. They'll do the initial sysprep, and then they'll actually finish the installation and join the DC once it's actually physically in place. And so you'll send someone who's reasonably competent out to do that. And sometimes, especially for industrial IoT cases, there's a lot more to do on site where you're actually doing last minute configuration because you don't have super great coordination between HQ and the rest of the locations. So in our point of view, you have all of these computers that are basically servers that are being sent all over the world to all sorts of locations. And this is a remote management problem. And these things they're not just print servers or old school sort of phone VoIP servers or anything else. These are real compute with real applications that deal with your intellectual property. And so what we view branches as is a sort of micro data center that is installed in hundreds or thousands of locations worldwide. And so we think that people should think of branch as, I need some compute capacity at this location, and I want to be able to manage it, and so on, and not our branch needs a print server, that kind of model.
So not what we would call a small robo, more like
definitely not a robo kind of branch. Although, I mean, robo should converge on uniformity.
Right.
I guess our maybe at this point tedious theme that we've been hammering you guys with is simplification and conformity and uniformity is actually where things kind of have to go, because the scale, essentially the scale of the number of compute units managed per unit in IT staff is not actually shrinking, it's actually going up. I mean, it's ridiculous to point it out, but at this point, if you do MDM and you manage mobile devices, just think about the ratio. Just be cynical about it. And like the ratio has gone up, but the staff sizes haven't actually increased all that much. And that's, we might go down that it's unfair, but it's also, it creates a situation where inevitably mistakes will be made. And those mistakes tend to be in the hard and complex areas. And security tends to be a hard and complex area. And so you'll end up with basically no security, but we'll come back to that.
So that kind of begs my question.
Sure.
What's the minimum size? Like how big is the
from our
smallest
point of
thing
view,
I
like
can
a
get?
single box, like we would, so I'm going to talk our game, right? So from our point of view, if you have compute resources in a branch office, and these are things running typically Windows, some Linux maybe Open Solaris if you're really strange, you're better off running those things as VMs and have an appliance that you can just drop them on, where you can drop that appliance into place and be sure that you can manage it remotely without touching it. I also think, and I don't think I'm unique in this position, that a lot of these branch offices are kind of going to give up the hub and spoke model, and they will be directly internet connected. So then you have another security issue on top of your normal security issues. Well, they'll be just direct to internet, or approximately direct to internet, depending on how you want to do it. Your headquarters DC is completely different from your branches. This goes without saying. I'm going to say it anyway. You've got really nice cabinets. They probably have locks on them. Those locks are probably very easy to pick, as an aside. But they're probably behind badged closed doors and so on. And you have a certain level of security there.
That was very Mortal Kombat.
Looks a little bit
might
like,
not be okay for the
Resident Evil.
Not the look, just the way he came up.
Yeah, fair enough. But your remote branches are a wee bit different. So you drop ship your boxes there, and then they kind of hang out on the beach for a while, and then they get installed at one of your illustrious global locations.
Is that the NASCAR slide?
Those look like Chipotle locations to me.
This is really...
I thought you guys called it a Formula One slide.
Oh, right. Ideally, if you're building these out, you want something that kind of works like this, right? I get a box, I ship the box, someone gives it power and Ethernet. It has 4 holes in the box to power to Ethernet, at least. And then as soon as it comes up, it finds its way to the internet, and everyone is happy, hunky-dory, and I can do whatever I want with it. I can push all the applications to it that I want to do. I didn't have to stage it at my headquarters to pre-install any software on it or anything else. I just ship it and turn it on. The problem with this is that that's kind of a little bit of wishful thinking, but we can do this. We're smart, so let's do this. So I buy a box from a known location, and I do all sorts of crazy stuff. Okay, I'll put a clean source copy of Windows Server on. I'll maybe do disk encryption. If I happen to have a TPM and that TPM actually works and it hasn't been recalled yet, I'll do all the latest patches and updates since it's inside my firewall and it's all cushy and warm. And I might, if this is an AD case, I'll make it a main controller because I want a remote ROAD or something like that. If I'm really hardcore, I'm going to pull the disks out so I can courier them alongside send them with the guy who I'm going to send out to rack it up. Yada, yada. I mean, these things can be done by people. And the practices that are necessary are not very common. And that's OK. People don't need them to be common. But the real question is, having done all of this, how am I sure that things are still good? And so then your issue starts to kind of look like this. Like we actually have customers and some customers that are in progress, potential customers, where they're actually concerned with like in-transit tampering. They're concerned with the bigger one, though, actually, in my point of view, the more legitimate one, if you're not someone who's dealing with very tight intellectual property. A bigger one is that the box falls off the truck somewhere in the middle of shipping and falls off the truck and is stolen and otherwise moved somewhere else where it can be used as like a server to attack people. This is actually not unheard of. It's actually kind of, it's not common to be sure, but it's been done. And so you kind of want some assurance that the thing that you're seeing that says, hey, I'm connecting to you is actually coming from a legit location. And it has not been tampered with and is not basically being used to explore your network. So you kind of want something that looks like this, where you ship a box to a location, you connect power and Ethernet, you have some way of validating the contents of the box remotely. You have some way of doing admission control, so you're sure that the box is who it says it is, that it has running the software and hardware that it should be running, and that it arrives and is under management. And then you're in pretty good shape, if you had this. So I think our battery is dying. And then you have the other issues. So you get it there. And then the question is, what happens when something goes wrong? So what you really want is the promise of what people used to call like lights out management access. Now they call it all sorts of different things, where no matter what, I can get on this box and I can fix it. And I don't have to go out to the cage. I don't have to go out to my data center. I don't have to fly out to the hut in the middle of Utah where this thing is sitting talking to my power generator. You really want remote management. What you really don't want is to like rely on smart hands. I'm sure everybody in this room has dealt with smart hands. Explaining to people what to type over the phone is possible, or even, I guess, texting makes it a little bit better, is brutally hard. And generally, your smart hands are contractors and typically from some service provider. And that's really tiring, and they're hard to deal with. And actually getting things back online as quickly as possible, which is your only job when something goes wrong, is challenged by that. So I think, all right, one more button press. OK. So what the net of all of this is that our view is that for branches, for the branch application, which is manufacturing locations, et cetera, you really need something that looks like this. So we got a good question a bit ago about why did we rebuild everything? And this was our starting point, actually. Our starting point use case was, in fact, I need to drop a remotely managed server in place, and I want it to be zero pain and zero touch. And that's how we ended up getting here. And so you build something where you end up with this, so you don't have to worry about these things. I don't have to worry about the software that was installed on it. I don't have to worry about the physical environment. I don't have to worry about the remotely piloted drone humans that are going to be doing my last-minute installation and updates.
Heath and I, as former Big Four consultants, resent the millions of dollars you're going to save people.
I'm sorry. And so this is what you want to end up with. So in a perfect world, you end up with a thing where I just have an app. It runs on some substrate that I don't care about and that I don't manage. And this is like, we've talked a lot about cloud during this conversation, and like a lot of that conversation is about the cloud management and deployment experience, where things should just work. I should have some compute somewhere. And I should know where that is, because location actually does matter, which is why I don't think data centers go away. But that shouldn't change the experience of turning something on. And I shouldn't have to have a huge local footprint there. Like, for example, if I were doing one of the customers that we lost and we didn't get them, they're going to stand up thousands of OpenStack regions all over the world because they're trying to get to this remote managed, I got VMs, I can deploy things. It's an interesting solution, and I wish them luck with it. But you really want to get to this point where it's like, I have this thing, it needs to run here, and I can just do it. And so that's our view of branches. And I don't actually have much to add to that. And I'm going to hand it off to Dan for a demo if you guys want.